Anyone who's been into automotive wiring will inevitably have come across the term concentric twisting, often used in conjunction with a professional or mil-spec wiring harness that we so often see at the top levels of motorsport, right up to and including the likes of F1, WRC, IndyCar, Le Mans, etc. Now, that technique has seen a lot of questions come our way. What is it? Why do we use it? And what's involved with doing it? So at the moment, I'm in the middle of one of our in-house projects, and I just want to take you through some of the aspects of concentric twisting, why we do it. We'll also look at a few of the tools that are involved in the world of building these professional motorsport wiring harnesses. Let's get started with concentric twisting and what it is. Here I've got a test piece of harness that I quite often use through some of our wiring webinars. Just kind of gives you a bit of an insight into the makeup of a concentrically twisted wiring harness. So we start with a core. In this case, which is quite common, we're using two core shielded wires. These are nice because they're quite bulky, they're easy to twist together, and that makes up a nice solid core that then is quite easy to lay up our additional twisted layers over the top of. And we're mostly going to be using the shielded cable for some of the mission critical sensors that are really sensitive to electromagnetic interference, the likes of our engine speed and engine position sensors. If the ECU isn't getting solid information from those sensors, it can't do its job properly. The rest is history. So the idea here is that the conductors are shielded, and the shield will absorb any electromagnetic interference and then drain it to ground. Anyway, that makes up our core. Then we've got our subsequent layers of our concentric twist. So each time we move from one layer to the next, the twist direction or the lay direction swaps from one side to the other. We've got, in this case, a range of 20 gauge conductors. Our next layer up here, we move to 22 gauge conductors. So this becomes our final layer just for our little test piece. And we've got the obligatory Raychem DR25 sheathing over the top of it. All right. Advantages with concentric twisting. Well, there are a few. The first of these is that the resulting wiring harness becomes very flexible. Essentially, each of these layers can move relative to the other layers. So you can actually get this harness and twist it through a fairly tight 180-degree bend. Now, the other aspect that goes hand in hand with this is that when we do twist the harness like this, because of the way the harness is constructed, no individual wire inside the harness has any more or less stress applied to it than any other. If on the other hand we were using a parallel lay for all of our wires and we bent the harness through 180 degrees like this, the wires on the outside of that harness would then be stretched, so applied much more strain than the ones on the inside, and that's not good for reliability in the long term. So that's one advantage. Two advantages really. The other aspect here is, as you can see, it gives us a very small bundle size for the number of conductors we are using, and it's a nice round cross section as well, and this makes it really easy for us to then install our sheathing over the top. When you are dealing with Raychem DR25, it's not going to work that well. It's not very easy to install if you are placing it over some haphazardly bundled together wires that are run in parallel to each other. Yes, it's possible, but it's not that easy, so this makes it really simple to install your sheathing. Obviously, the other aspect here is it gives a nice aesthetic look to our finished harness, and let's be honest, yes, this actually is reasonably important. We all want to take pride in our work. Building a harness that looks like this, we can take some satisfaction in doing it. All right, we've talked about the advantages here, but of course in this world there are no free lunches, and concentric twisting does come with a few downsides as well. The number one that you need to consider here is the time involved in building a concentrically twisted wiring harness. There's a lot more planning that goes into the documentation and design for a concentrically twisted harness. Not only do we need to know where every conductor goes, that'll be the same for any harness, we also need to give some more consideration to whereabouts in our harness each conductor is, and this helps us with our transitions where we're breaking out individual conductors at a transition point in our harness. Ideally, we want all of those transition wires or conductors to be in the same layer. It's going to make our job a lot easier later on, so putting some extra time into the planning really can pay dividends. Then there's the actual aspect of laying up the concentric twist, and again, this takes time, particularly if you aren't doing this every day. When you come back to it like I do occasionally to build a harness, it does take a little while to get back on top of things and master the techniques involved. Now, other aspect that is worth mentioning here is with a concentrically twisted harness, there are a specific number of conductors that we need to put into each layer. As we step from one layer to the next, essentially what we're doing, as long as we're using the same conductor size, we're stepping up the number of conductors by 6 compared to the underlying layer. What this means though is when we get to that outside layer, we have a specific number of conductors that must be in that layer. And more often than not, we're not actually going to have the correct number. Often we're going to end up falling short, sometimes by quite a reasonable margin. And we can't just lay up any number of wires in a layer. What we actually need to do then is essentially pad this out or pack it out using filler or ballast wire. So obviously there's two aspects when we're adding ballast or filler wire into a layer. It's going to add weight and it's going to add cost because we have to pay for that wire as well. So that is one consideration. Now, often this is used as some future proofing though. If you've got spare inputs and outputs on your ECU, you can actually terminate these to the ballast wire and then bring this out as a spare connector in your harness, which you can then adapt into at a later point if you want to modify the harness and add some new sensors or some new capabilities to the harness. The other consideration when building a harness at this level is that while it's not an absolute essential, most often we will be using these round Motorsport style connectors for our terminations, particularly at the bulkhead where these can be a quick disconnect. The whole wiring harness can come out with the engine. We can also go a little further, and with harnesses at the top level, we'll find that all of the factory sensors and actuators have been potted and terminated in smaller Motorsport connectors for the best possible reliability in the long term. It's not just these connectors though that we need to worry about. In order to get the best results with those connectors and get the reliability that they can offer, we also need the correct crimp tooling. In this case, the industry standard for working with Motorsport connectors is the DMC or Daniels Manufacturing Corp crimp tool. This is an AFM8 that I've got here. Now, if you are considering purchasing one of these, yes, the genuine DMC crimp tool is a little bit spendy. There are some cheaper knockoffs coming out of China. I would advise against purchasing a knockoff. Yes, it's going to be an expensive purchase. This, if you look after it, is going to last you a lifetime. It's guaranteed to give you the best results. There's no point spending all of the money building a professional motorsport wiring harness and then having one of your crimps fail because you've used substandard crimp tooling. The other aspect with the crimp tools is that they work in conjunction with this little positioner that we've got here at the end of the crimp tool. Now, there are a range of these positioners available depending on the contacts that we're working with, so it's important to choose the correct positioner based on the size of the contact you're working with and whether you're working with a pin or a socket. So that's essential. Then make sure that the contact that you're about to crimp is going to be positioned correctly inside the body of the crimp tool so that the crimp is going to be applied in the correct place. Installing these is really easy. Just press them down. They are spring loaded, little half twist, and they'll click into place. It gives you a nice positive feedback when it is in location. Now, there is also some information on the top of the positioner. So this will tell you, based on the wire gauge that you are using at the time, which position this little rotary adjuster needs to be in, and essentially that rotary adjuster affects the amount of pressure being applied by the crimp tool. Again, absolutely vital to make sure that you are not under crimping or over crimping the contacts that you're working with. The next question that comes up from those who are new to working with Motorsport connectors is, how do you know which positioner to use for a particular contact? Unfortunately, TE offer this in some technical documentation. There's a simple lookup chart there which defines for a particular contact size, whether it's a pin or a socket, which positioner to use. There's also a little color code reference on the contacts themselves, which you can reference to that chart so you know that you are working with the correct component and you've got the correct positioner to get the job done. Another thing we need to consider, regardless of what terminals or contacts we are working with, is stripping the insulation off our wire. And what we actually need to do here is get a specific strip length. What we want to do is make sure that we've got full engagement in the contact that we're about to crimp. And you'll find there is actually a small viewing window in the side of the contact, and we should be able to see the conductor strands visible through that window. But we also actually want to have a little bit of exposed conductor at the back of the contact. We don't want the insulation around our wire to be hard up against the back of the contact, because again, if there is motion placed into that wire or movement placed into that wire, if the insulation is hard against the back of the contact, this can induce some stress, which can again be a point of reliability problems. And when we are working with these Autosport connectors, in the case of the one I'm working with here, it has 79 positions, we're going to be stripping the insulation off a lot of wires. So we need a reliable way of consistently getting the right strip length. And that's where a quality set of wire strippers is critical. These ones are from Ideal. They're the Ergo Elite range from Ideal. And first of all, one of the features of any wire stripper that's used in professional motorsport wiring is that the blades used for stripping the insulation are designed for our specific wire. There's a range of different locations there that you can use depending on the gauge of wire. This is really important because what it's going to do is make sure that it cuts accurately through the insulation around the wire without damaging the underlying conductor strands. So anytime you're wiring, using a pair of side cutters to strip the insulation off the wire, that's a big no-no. You can easily damage the underlying conductor strands. And if you've nicked or cut through a few of the underlying conductor strands, what that's going to do is end up affecting the current handling capability of that wire. If you are operating near to the maximum current that the wire can handle, you can end up running into problems. So correct wire strip is essential. Now, why I like the Ergo Elite is it also has this optional adjustable stop. So what we can do is set up the stops so that we're going to get consistent strip length on all of our wires. So let's go ahead and do this. The wire I'm using here is a 22 gauge wire. We'll get it located in the correct place. Simple action there, and we've got our underlying conductor strands exposed. What we can do now is we can get our contact here, our little 22 gauge pin, and we can slide that into place. Now I made that look easy. When you're dealing with 22 or 24 gauge wire, this actually can be quite tricky. But what I'm looking at here is I've got a little bit of exposed conductor strand here. Generally I'm aiming for around about 0.5 millimeter. We don't want too much, or we could run into problems with the conductors actually contacting each other within the back of the connector, particularly with the high density range from Autosport. But in this case, everything's looking good there. Once I've done that, it's a simple case of opening up our DMC crimp tool. We can locate that into the back of the crimp tool, making sure that it is firmly and positively located. Simple operation, the crimp is complete. We can also view our finished crimp, and this is often easier to do with a magnifying glass, making sure that our crimp is complete, that we haven't ended up contacting that little window, viewing window in the side of the pin, and we also want to make sure that our conductor strands are visible through that little window. We've done that, everything's looking good. We've got a finished crimp, and we can now install that into our connector. Once you've completed the crimp, the next operation obviously is to insert the contact into the back of your Autosport connector. To do this, we're going to be making use of the little insertion and removal tool that comes with the Autosport connector. This green and white version here is used for 22 gauge contacts, which is what we're working with. The green side is for insertion. So what we're going to do here is, we'll see there's a slot up the back of that tool. We're just going to take our wire, and using our thumb, we're going to slide that into the tool. It's actually pretty easy to click it into place. Once we've done that, we need to slide the tool down until it's sitting just on the back of the collar on that contact. Once we've got it in location, we're then going to find the correct pin location in our Autosport connector, get the tool lined up, and we're just going to gently push this into the back of the connector until we feel a click. While we're doing this, it's really important to make sure that we are inserting square to the Autosport connector. So let's go ahead and do that now. All right, nice little click. I know that's in place. We can pull that back, and we can then simply remove it off our wire. So at this point, we've got our wire, our conductor, and our contact correctly installed into our Autosport connector. No matter how careful you are, at some point you're probably going to get this in the wrong location, and that's where the white side, the removal side, comes into play. Basically, the operation is the same. We're just going to slide the wire into the removal tool. We're going to slide that down gently insert it through the insulator at the back of the Autosport connector, and we'll just push that into place. We'll feel it positively engage in the back of the connector, and once that's done, we can just clamp the wire to the back of the tool and remove the pin. So that's as easy as it is working with Autosport connectors. Let's get this back installed and we'll have a look at the next task on our list. If you've been following the Instagram accounts of any of those who are building these wiring harnesses for a living day in and day out, you've no doubt seen some photos of the back of the Autosport connectors before the heat molded boot goes in place with little loops of wire. And you might be wondering to yourself, what's that all about? So these are called service loops and sometimes referred to as strain relief loops. Basically, it's just a little loop of wire that's there to serve two purposes. The main one is that that little loop of wire gives a little bit of additional length that helps in the case that you need to modify, deepen, or effect a repair on the back of that connector. Now, hopefully that's not going to be the case, but there it is. That's what we can do. The other aspect here is that it does provide the potential for some strain relief. Now, it's not necessarily its key function in life. The service loop aspect, the additional wire, the ability to deepin and repin that particular location is really its key aspect. But because now the wire is not tight to the back of that contact, any stress and strain or movement that's placed into the harness behind the connector is not going to be transmitted directly into that contact. Instead, we've got this little loop of wire, which I've kind of over exaggerated like this, so it just ends up putting the stress into that little loop of wire. Now yes, the rest of the harness should actually be supported and strain relieved anyway by the heat molded boot. Generally this will be also epoxy glued to the DR25 sheathing that goes around it, but still any potential advantage we can get is going to be helpful. So how do we perform these strain relief loops? And there are some actual professional tools that you can purchase, but it's not really that necessary. All we need is something like this stainless steel pick here, and we want to basically wrap our wire around it and form a tight little loop around the pick. You can use a screwdriver for the same purpose, and there we've got our little strain relief loop. Now, of course, that's going to be much closer to the actual contact, but the process is still exactly the same. At the moment, I'm just getting set up to add our coil wiring into the Autosport connector. So we've got all of our wires here for our power supply, as well as our trigger wires for our coils ready to go into our Autosport connector. And this is a good time to point out something that is worth keeping in mind when you are selecting your wire. We can see here we've got these sections which are really tightly coiled. We've got this section up here, it's exactly the same length, but you can see how much freer that is. Might not seem like a big deal, but the reality is that it does make a big difference when it comes to actually doing our concentric twist. So why have we got the difference between those sections of wire that I just showed you? Well, when I ordered materials for this particular harness, I ordered 100 meters of 22 gauge white wire. It's a reasonably large size order. It came on this spool here, as you can see. Reasonably large diameter spool. Turns out that 100 meters wasn't actually quite sufficient, and I ended up having to resort to some other stock I had on hand, which comes on this much smaller spool. Obviously the smaller spool, the wire is wound more tightly around that. When you take it off the spool, it wants to revert to its existing size. That's why I've got those tightly wound bundles of wire. Now this might not seem too meaningful. The reality, however, is that it does actually make our life a little bit more difficult when it comes to building that concentric twist. When we are concentric twisting, what we're doing is hand laying the wires over our core. And as we do this, we're going to be using maybe 4 or 5 wires at a time. We don't try and do the entire layer in one shot. As we twist them around, the ends of the wire inevitably end up getting tangled up. There's nothing we can do about this. So it's a process of just performing 1 or 2 twists of our wire, and then we want to untangle the ends so we can continue. Otherwise, you're going to end up with a big old bird's nest at the end. Now, when we are dealing with wire that's already tightly wound like this, it makes it much more susceptible to becoming a bit of a mess. So if you've got the option, working with a larger spool of wire, it just simply makes your life a bit easier. All right, we've covered some of the basics. Let's actually dive into how we go about building this concentrically twisted harness. All right, we've got our section of harness here that we're working on for our project. and this is made up of 79 conductors in total. The core is made up of 3 sections of 2-core shielded cable, and again that's twisted together to make a nice, easy to work on core for our subsequent layers. We're now working on our last layer, so this is the 4th layer in total. I've actually already gotten started, but we're going to go through the process so you can see it in action. Before we do that though, let's have a quick look at the setup here. Now, while it might look like a bit of a bird's nest at the moment, don't worry, this is all going to start making sense soon. I'm using these little bench vices at both ends just to support the wiring harness, and while it's not essential, it just makes life a lot easier. Now, as we're working down this, we can see this is the section that is nicely twisted together at this point, and this piece of orange or goldy tape here, this is capped on tape. This is going to be my first branch point, so this is why after this branch point, we can see that it's still twisted together, but I haven't gotten too fussy here because essentially a lot of this is actually going to come apart for our transition. So we just need to keep it in some semblance of order because we're still going to be slipping DR25 over this to sheathe our section back down here. So you can see that the layup that I'm starting to work on at the moment, we've got 1, 2, 3, 4, 5, 6 wires that I've just started with. And this is the most important part. When we've got a layer which has, in this case, I think 32 conductors, we can't possibly hope to get a result by twisting all 32 together. So it's a case of taking 4 or 5 wires in one go and working that around, making sure that we don't have any kinks, we don't have any conductors lying on top of each other. It's really easy to work those through when we're in this stage here, rather than once we've got the entire layup complete. So let's have a look at the process and we'll carry on. What I'm going to do now is take my next section of wires, and I've got 4 wires here, and we're just going to start laying those up over the ones I've already got. Now, another important aspect here is I am using a cable tie just to support the wires as they come off the back of that Motorsport connector. And you can even use another cable tie that's a little bit looser that you can move down as you perform your twist, just to make sure that nothing gets mixed up or jumbled up while you're actually performing your twist. So we're going to get our 4 wires now, and we're going to just bring those over the top, making sure that they're sitting nice beside the wires that we've already got in there. So at this stage we've done 1 twist there, and this is what I was talking about before. We need to constantly be making sure that the ends of our wires are untangled, otherwise we're going to find it really hard to make sure that those all sit nice. So let's just carry on now with our twist. At this point, I've got those additional wires laid up to my transition point here. So from here, I'm just going to wrap those a little bit less precisely around the rest of the harness. Again, we're not too worried about those. They're going to need to come apart once we do our transition. From here, it's a case of rinse and repeat. We're just going to pick the next 4 or 5 wires that lay beside the ones we've just dealt with, and we're going to continue and lay those up. So let's watch that process. All right, there's our final layer complete up to our first transition point. So let's take a closer look at it. So you can see we've put a cable tie around the end here just beyond our branch point. Final step of this would actually be to add some capped on tape and some Kevlar lacing cord just to keep this all neat and tight while we are installing our DR25. We've got the end of our Motorsport connector there. We can see we've got our service loops there. Still a little bit of work to do to tidy that up before the heat molded boot goes on. But essentially our first section of harness is complete, ready for DR25. While concentric twisting isn't a technique that is necessarily going to lend itself well to every harness job you're going to complete, as we've mentioned, there are a significant number of pros. If time and money aren't your main priority and you want the best possible result for a reliable harness that's going to last the test of time under a harsh motorsport environment. In this video, we've obviously just had a brief look at the concepts behind concentric twisting and some of the aspects that go into the development and building of that harness. If you do want to learn more though, we have a complete course that covers everything you need to know. You can click the link in the description below to learn more. If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.